Welcome, historians and lovers of all things history. The Construction History Society of America is pleased to present this one-hour webinar on Metals Through Time, the third such event that details interesting stories around construction history. I am Peter Hilger, the University of Minnesota faculty in construction management and president of the Construction History Society, and I will moderate this session. I'm accompanied by Clifton Fordham from Temple University. Give them a wave, Clifton, so they know you're here. We'll monitor your questions that you can submit via the Q&A or chat function. Melanie Fierst, our executive director, is also joining us on this Zoom stage, so to speak, as executive director. She will take the torrent of membership requests that you will want to have after this presentation. And finally, hiding in the background is Paul McLagan, my colleague here, who is manning the Zoom trolls. So thanks, Paul. It's now my pleasure to kick this storyboard off. Today, we welcome three presenters who will fly through distinct narrations on construction history, including Sara Wermiel on the introduction of the I-beam, Tait Johnson on the rise of Coinier, and Kevin Vasquez talking about a local to Minneapolis restoration project. So with that, I'm going to introduce our first speaker, Ms. Sara Wermiel. Sara is well known to our society. She's an independent scholar, historic preservation consultant, and a teacher. Her research focuses on the history of 19th century American technology, industrialization, and urbanization. She is well published on the main subjects of her research: structural fire protection and the development of new materials and assemblies for constructing buildings. So Sara, tell us about the rolled I-beam.
Okay, I hope everyone can see that and hear me. Yes, okay. So thank you, Peter, and welcome everybody to this webinar. Today, I'm presenting my research about the beginnings of I-beam rolling in the United States. So the I-beam, as you undoubtedly know, is a metal structural member that in section is shaped like a capital I, and it's rolled of wrought iron or steel as a solid piece, not fabricated from several pieces as are plate girders. The focus of my presentation is the first two firms to produce rolled wrought iron I-beams in the US, Trenton Iron Company and Phoenix Iron Company. And I've titled my talk, The Introduction of the Rolled I-beam Revisited, because there are several articles and a short book about the beginnings of I-beam rolling in the US. And my research updates this literature, in particular with regard to Phoenix Iron Company. But for context, I'm going to begin with the introduction of I-beams in buildings and I-beam rolling that preceded the manufacture of I-beams in the US, in France, and Great Britain. So iron beams were first used structurally in buildings, principally as substitutes for wood, as a fire safety measure. The earliest iron beams were used in a floor system where the beams were made of cast iron and there were brick arches spanning between them. This system originated in Great Britain in the 18th century. And this is an early example of this kind of floor in a textile mill. These floors with iron beams were called fireproof floors. And they were made with cast iron beams, as I said. And in this case, the beam is an I shape. Whoops, why is it doing that? Okay, so the I shape in cast iron was well known in Great Britain for use in this brick and iron floor. And this is an example from an architectural writer from the 1820s showing, his recommendation for this beam. Okay. So meanwhile in France, specifically in Paris, these fireproof floor systems emerged, but they didn't involve cast iron beams. Rather, they were made of iron embedded in plaster. But in France, the first rolled I-beams were produced around 1846 by a Parisian ironworks, and they were used as rafters. For some reason, my PowerPoint is advancing by itself. They were used as rafters in this train station, Saint-Lazare, and this was in the late 1840s. And by the 1850s, rolled iron beams in France, these small iron I-beams, were a commercial product. And this is the application of the iron beams in France in this period in these fireproof floors. So you see they're small I-beams, they're mostly embedded in plaster. So it was a somewhat different system than was used in Britain. So that was the late 1840s, commercial product by 1850s. Meanwhile, in Great Britain, although Great Britain pioneered use of structural iron in buildings, they were not using wrought iron, they were using cast iron. The earliest wrought iron I-beams were probably produced about 1852-53. Again, the application was in these fireproof floors. This kind of floor is like the French floor, although it involves concrete and the iron beams. Anyway, rolled wrought iron never became a commercial product in Great Britain because they were able to import cheap iron beams from the European continent. And so it's just less is known about how, the history of the iron beams in Britain, but it was probably the early 1850s, the first ones were made there. So meanwhile, in the US, iron production is practically unknown. I mean, iron use in buildings is practically unknown. That was mostly a function because of the limited amount of iron. But as you see from this chart, as iron imports and domestic production increased in the latter 1840s, that's when iron begins to be used in buildings in the United States. Now, on to Trenton and Phoenix. So it was in the 1850s that two American ironworks, Trenton and Phoenix, set out to manufacture rolled wrought iron beams. And I'll talk about Trenton first. So this company started in South Trenton in New Jersey. Initially, they were set up to roll railroad rails, but making T-rails. But around 1850, Great Britain began to dump rails on the American market, and practically all the American rolling mills went out of business. And so Trenton and also Phoenix started looking for a new product for which there wasn't foreign competition, and they decided to make rolled structural shapes. So they anticipated demand for these in buildings. The headquarters of the company that owned Trenton, which was Cooper and Hewitt, was in New York City. Lots of valuable buildings being built there. They thought there would be demand. So they set out to try to roll these I-beams. However, they had no success they had a lot of trouble. So initially they offered a beam made of two channels that were attached together in the middle. And the first project to use those double channel beams was this building, which is behind the bank building. You can see where the arrow is and then on plan. So it's sort of hard to see anyway. This was 1853-54 that these double or compound beams were offered, and they were used in this building. So this is like the first wrought iron beams used in the United States. Meanwhile, they continued to try to make real, I-beams. A second customer was this Harper and Brothers, whose plant burned down, and they wanted to rebuild fireproof. This was also, the fire was in 1853, so in 1854, their offering beams to this company to rebuild fireproof. And what's interesting, this is that building being demolished. This is on Cliff Street, New York City. And you can see the seam there on the beam. So that is an indication that these are double beams. These are not solid rolled I-beams that were used in this building. So these are the compound beams to reconstruct this building. But the company kept trying to make rolled iron beams, and around in the spring of 1854, its next, what it offered was a rail beam, the one on the right. So this worked as a beam. However, and it was 7 inches tall, it was about 27 to 30 pounds per foot, but it was not a symmetrical I-beam. It was more like a tall railroad rail, but it worked as a beam, and they began shipping these as beams. And one of the early customers for these rail beams was Peter Cooper, father of Edward Cooper, one of the owners of Cooper and Hewitt. Anyway, he was building what is now known as Cooper Union, then Cooper Institute in New York City, a fireproof building. And some of these rail beams, well, at least in the 1970s, still survived in the building. So you can see there in this Habs photo, a rail beam. But the company is still trying to roll symmetrical I-beams, and 9 inches tall, that was its goal. And this machine was what it finally used to successfully make these beams. You can see the roll at the top there that I've circled. Those were the finishing rollers for the beams. And this was a 2-high mill. It was not very successful. It was ultimately replaced, but this is an interior of a rolling mill. And on the left there is the 2-high mill. You can see because they're actually dragging the beam over the top rather than just doing a reverse roll as you would have with a 3-high mill. Anyway, so by the summer of 1956 or fall, Cooper and Hewitt had succeeded in making I-beams. And just to show you, this is the application for the beams at this time. It's between a segmental brick arch leveled up with some kind of concrete. Okay, so now Phoenix, this company was long time in the Reeves family in Phoenixville, Pennsylvania, and they also owned a plant, well, they built it in 1847 to make rails on the Susquehanna River. So that's about 60 miles from this plant in Phoenixville. However, it's pretty certain that the beams that were rolled were here at this Phoenixville plant. So Phoenix Iron Works also was hard hit by the foreign competition in the early 1850s. And so that's when it too started looking to produce I-beams as a new product. Unfortunately, unlike Trenton, the business records from the 1850s for Phoenix Iron Company have disappeared. They just don't survive. So it's a lot harder to pin down exactly what was going on. There are secondary sources and later reminiscences where people say that the company started rolling I-beams in 1851. There's just no confirmation of this. Other sources say 1855. That's conceivable, but anyway, as I find, the one date we can say confidently is 1856. So the earliest contemporary evidence I was able to find that they actually were rolling I-beams commercially was exchange of letters between Cooper and Hewitt and Phoenix. And it concerned bids for buildings that were seeking I-beams. And one of the buildings was the Pennsylvania Railroad Company offices in Philadelphia. This building is long gone. But anyway, Phoenix and Cooper and Hewitt were complaining to Phoenix that it was underbidding it for beam contracts. So these letters are in the early 1857. So clearly both companies had beams to sell by late 1856. And also they were offering both 7 and 9-inch symmetrical I-beams. So we know that both of them were rolling those beams by late 1856. However, Phoenix began to roll larger and heavier structural shapes than Trenton at an earlier date. And by the Civil War, it was making wide flange beams. And what gave it a technological edge over Trenton was that its superintendent at Phoenixville patented in 1857 this way of rolling beams where the flanges were pre-rolled and then a pile was made for the web, and then this was all put through the rolls. And by pre-shaping the pile, the metal had to go through fewer passes. There was less unequal strain, and the result was fewer defective beams. So Phoenix became a structural iron erecting company and established a subsidiary bridge erecting company. And the structural shapes that it used in its bridge and so forth manufacturing were all made at Phoenixville, including the very well-known Phoenix column, which is what you can see here in this picture. So to conclude, which company, Trenton or Phoenix, was the first to roll 9-inch I-beams? It's, we don't know, down to the minute, but it's for sure both were rolling them by the second half of 1856. And then very soon other mills entered this market. So the US was well supplied with American-made wrought iron I-beams from the late 1850s on. American beams were available in a range of sizes and weights from this early date, which opened up structural design possibilities for American architects and engineers. The availability of wrought iron structural shapes and columns led to large, structurally novel buildings, which advanced technologically towards skeleton frame construction. Thank you for your attention.
Thanks, Sarah. We have time to fit in at least one question before the next speaker is ready. Just want to remind the audience that we will have some time at the end of this event for basically questions aimed at the panel or specific individuals on the panel. So this question comes from Dennis DeWitt, and it is, weren't all British railroad rails that flooded the US market effectively rolled wrought iron beams?
Well, thank you for the question, Dennis. You could use a rail as a beam. It wasn't much done. There's a famous case of a building at Princeton University. I'm blanking on the name of the building. However, where rails were used as beams. But by the time people were, building these kinds of floors, by the mid 1850s, the beams were available, true I-beams. So those were, for the most part used. But indeed, you could use a rail. The average T-rail, by and large, was short. Was 3 or 4 inches at most. So it wasn't as convenient as even the 7-inch rail made by Trenton.
Great, thanks, Sarah. It looks like questions are starting to accumulate. So what we'll do is, it looks like Tait's ready. We'll segue into his presentation and then revisit any questions for you.
All right.
Thanks.
Thank you, Sarah. Thank you, Clifton. It's now my pleasure to introduce Tait Johnson as an architect and architectural historian teaching at the University of Illinois Champaign-Urbana. His research examines the history and theory of modern architecture and materiality in the 20th century, specifically concerned with the image and instrumentality of metals in architecture. So Tait, why don't you take us through the rise of coir?
Great, thank you, Peter and Clifton, Melanie. Thank you so much to the organizers for inviting me, and great to see all of my co-presenters here, and great to be with everyone else here on the Zoom call. Let me share my screen here and get started. So I'd invite you to email me at any time after the presentation to continue the conversation to talk about one of my favorite topics, metals in architecture, or any adjacent topics as well. Well, I want to talk about the origin of coir, because I think we can look at manufacturers and I think we can learn a lot about the development of modern architecture, and coir played a significant role. Now, the center of gravity of this presentation is Niles, Michigan. You can see the maps here on the screen. But I'll also branch out to look at storefront facades in other countries where coir products were sold. So here we see the location of Niles, southeast of Lake Michigan, the hometown of coir, until actually the late 1970s when it moved to Georgia. But I visited Niles and several other small towns and learned that many ideas about modern architecture were tested out in these small towns before making their way to larger buildings and skyscrapers or office buildings in larger cities. So I visited Niles and saw how it was used, among other places, but very significantly here, as a testing ground for coir's storefront and facade systems. So they brought in and sold facades and storefront systems like we see here on the screen. We see a close-up here of a copper storefront framing system here. And then on the right screen, in the 1930s, coir largely switched to using aluminum. So we see some aluminum facades, aluminum framing around plate glass windows. But I'm going to promote two main suggestions here. And the first one I want to promote is there on the left, that modernism emerged in small Midwestern towns concurrently with the tall modernism of urban centers. And I think my assessment is that the tall urbanism, the tall modernism sort of overshadowed these simultaneous developments. But I also think that manufacturers' roles have been overlooked. That manufacturers played a defining role in architecture, in modern architecture, and it often preceded the popularization of styles and modes of design by architects of the historical canon, the more famous and well-known exemplars. I want to start with Francis Plym, the founder of coir, born in 1869, died in 1940. And he was born in Sweden. His father was a carpenter, and Plym did carpentry with his father to pay for his education at the University of Illinois. He graduated in 1897. He was very technically oriented. So when he graduated, he worked here, or rather he worked in Lincoln, Nebraska for a time, then moved to Kansas City to work until around 1907. In this time period, he became very interested in how to improve the frame around storefront windows, which at that time were largely wood. And he observed, like many others had observed and wrestled with for years, the sweating of single pane plate glass windows, sweating because of the temperature differential on the inside and outside of the window, which would lead to condensation. That condensation would drip down, down, down. He was interested in an improved system and patented over 125 different approaches to this. Well, he started his firm, coir, in Kansas City, near the Kaw River, the Kansas River, actually shortened to the Kaw, which is why it's called coir, but then moved the operation to near Chicago. He was enticed to and wanted to move the corporation near Chicago for its proximity to bodies of water for transportation and the robust rail network in the Chicago area. So he ended up settling in Niles, Michigan. And there we see on the right side, the plant. I'll show you a quick view inside the plant here of seeing a group of presses. So inside the plant were presses and brakes and other accoutrements of metal forming and shaping. Well, here's an image here of the first, the patent, the sort of patent that got Conair started. Metal sash, early design of in copper of the resilient metal frame, as he called it. And what it did was it was a metal frame grip around glass. You can see the glass there kind of rendered in the middle that allowed the glazing itself to give in displacement of the window in reaction to lateral forces, lateral loads like wind or people that might push up against the window, vibrations. He evolved a plan whereby storefront glass could be set directly between two metal bearing surfaces we see here on either side, without the assistance of putty or cork or wood or any other sort of cushioning, sort of a clamp system. And there's a section we can see on the screen. We see the glazing, the sheet of pane of glass coming down, sitting on a stopper of leather. And then on the inside, and I'll draw on the screen right now, on the inside, the condensation would accumulate and run down into this channel. So it had several functions, and it was all held together, clamped together by this bolt, screw and bolt system. Not only the horizontal, but also the verticals were designed very minimally here. Vertical bars, part of the frame, devoid of ornament. And deployed first on what they claimed was the first, as they said, modern storefront. They use that term, modern. The significance of this building is, I think, that it suggests modern architecture emerged even in the smallest of towns in the Midwest of the United States, not only originating in Europe, not only originating in the large urban centers of the United States, but concurrently in small towns as well. Conair described their storefront in this way. They said, and sort of listened for the hallmarks of modernism here as I describe, as I read what they wrote. They said, every feature incorporated in Conair is there because it's needed. There are no unnecessary parts built in to cause complication. They said, Conair is simple of construction, it's practical and design can be installed by any mechanic using ordinary care. They also wrote, Conair is not and has never been an imitation. So here, I think we hear all the hallmarks of what many would come to understand as modern architecture. It's very rational, only what is needed, devoid of ornament, simple, practical, standardized. They deployed this modern architecture, as they termed it, all over the country, South America, Europe, and Asia too. Here we see a storefront utilizing Conair metal systems in Russia in 1912. And over 50,000 storefronts had been sold by 1917. And that continued to accelerate into and after the Great Depression and into the 1930s, bolstered by the modernized Main Street initiative of the New Deal, this modernization credit plan, in which funds were available to merchants to renovate and repair their storefronts as part of the New Deal. Gabrielle Esperdy has written a great book about this phenomenon, this occurrence called Modernizing Main Street. It goes into very great depth. But Conair's clients and customers took advantage of this in the 1930s. Here we see Arnold's in Chicago, but also internationally. They didn't get the grant funding, but they sold overseas. Conair did. In Germany, in New York City here, we see another storefront on Fifth Avenue, and then back internationally as well, back in Sweden. So tens of thousands of storefronts until they were cut short by World War II. So their business was rapidly accelerating, cut short by World War II, at which time all of their production capacity was dedicated towards the war effort, manufacturing primarily gun turrets, the chin turret, but also many, many parts of the bombers in World War II. And they produced this float to promote their war efforts and the float of all the parts that go into like this wing section here, and the gun turret here on the end of the float to promote their activity in the war. During the late stages of World War II, they they invited in famous architects such as Morris Ketchum here on the left and Mies van der Rohe on the right, as part of what they called Storefronts of Tomorrow competition and initiative. They hired these architects to work with them and develop some recommendations on how they could sell and spread their products after World War II. And this commission of architects, along with Conair representatives or Conair people as well, they recommended that storefront planning should be comprehensive, not as a single store, but as a group of stores designed all at one time after World War II. And so Conair took that initiative and titled it A Plan for Modernizing Main Street in the context actually of much post-war planning across the country by many agencies, by many companies. Andrew Shanken wrote a great book entitled 1940X that looks at the practice of post-war planning and its influence on urbanism. And Conair was part of this as well. So they framed the need in their mind to comprehensively redesign every facade all at once in terms of economic activity, more pulling power, as they termed it, and hired and worked with Ketchum, Gina, and Sharp too, and I'll draw on the screen, sort of comprehensively all at once design renovations for the entire street front facade, entire districts of downtowns, they hoped. But as part of that comprehensive entire downtown approach or street front approach, they designed several prototypes, and what they called these were machines for selling. So the machine for selling was a prototype store. The larger landscape of machines would be all the machines for selling together. And this was the prescription to stop people on the street, to show them through the glass and to bring them in to buy. As they said, you can make a community a more important shopping center. You can induce more people to spend more money in your city. So they imagined that architecture could make people buy, and that the end goal for Conair was, yes, to make profit, but they also wanted to promote this as a means to a prosperous community, not just trying to convince the merchant that he would or she would be more profitable, but that it would in turn, and as a final result, be a better community. Well, what do these machines for selling look like? The prototypes look like this. For instance, here in plan, I'll draw on the screen, you can see how the facade of the prototype is pulled away at an angle from the sidewalk to sort of, in their mind, pull people in off the sidewalk and into the store to do their shopping, to buy, and then leave. That's one prototype amongst dozens and dozens and dozens of prototypes for many different store varieties, whether it be clothing stores, food shops, appliance stores like we see here on the screen. But they all promote the use of metal framing and glazing as this sort of initial first step in the process, in the buying process, as this machine for selling. Well, that was the vision. That was the vision in the 1940s, 50s, and 60s. Didn't come to fruition. Of course, many downtowns were renovating and revitalizing in those years as well, as a reaction to the developing regional shopping center phenomenon, AKA malls, that they were threatened by. But in the 1970s, finally, as we see here, Conair was successful in convincing entire street fronts of merchants at a time to clad their buildings in this product I'm highlighting on the screen right now called Shadow Form. It's a brown, vertically ribbed aluminum product that covered the entire facade. So they focused less on the sort of street front here, during this time period, and more on convincing all of the merchants to clad their facades in this shadow form. Not all of them, but almost all of them did. Here's a source that Mike Jackson highlighted in his article, Storefronts of Tomorrow, many years ago, showing how this shadow form and other products like it, called slip covers, were installed on top of frames, the frame on top of repaired and improved masonry, which then took the place of and removed many of the ornaments of the facade itself. And here I'll finish up with just a couple more slides. We see some remnants of shadow form today. You can see it's very faded today, but some merchants still have shadow form on their buildings, building owners, vertical ribbed aluminum product. Today, almost all of the shadow form as this comprehensive machine for selling has been removed. It's been removed actually in the early 2000s as part of a new initiative that the city of Niles claimed was a new modernization program to revitalize the city, not this time by putting aluminum facades up, but by taking them down via state and federal grants, which funded the removal of the aluminum. And by the way, Conair also kicked in some funding to help remove them, sort of an irony. But today, Conair, you may know, is owned by Alcoa. It continues to manufacture storefronts and building facade systems under the Conair brand name, which shows how influential manufacturers have been, in addition to the creativity of architects in defining modern architecture. And in small towns, these systems for cladding and framing, they developed early in the century. These towns were sort of proving grounds that were, the products were then deployed on larger buildings in commercial centers. So I invite scrutiny of other manufacturers to see how they may have had similar impacts on the built environment.
Wonderful presentation. I'm going to fit in one question before we transition to Kevin, and it comes from our audience member. I'm going to contextualize it. You started with copper as the initial material for Conair's systems, and we know them for aluminum today, and the majority of the systems are aluminum. So the question is, were the first storefront frames made of aluminum or steel? So basically the question is contextualizing, or at least placing steel within this continuum.
Yes.
Clarify?
Yeah. Sorry, I heard a echo there. Steel, yes. Wood also, but that was what Francis Plim was reacting against: the rotting of wood, and to a lesser degree the rusting and deterioration of steel from the water itself. So they first switched to copper, then brass. They maintained copper and brass and nickel actually for many, many years, many decades, until the 1930s, when they almost completely switched to aluminum.
Thanks, Tait. And Peter, I'll concede to you.
Okay. Thank you. And for our final speaker today, I'm pleased to introduce Kevin Vasquez, a structural engineer specializing in the diagnosis, analysis, and repair of existing buildings, construction systems, and materials. Educated in Mexico City, the UK, and Portugal, he holds an advanced master's in structural analysis of monuments and historical constructions from the University of Minho in Portugal. He's local to the Twin Cities. Kevin will talk about our neighboring institution just on the other side of town, the Dunwoody Institute. So Kevin, you can take it away.
Right. I think I'm sharing my screen, right? Can everybody see my?
Yes.
Okay. Well, Peter, thank you very much for your kind introduction. I just wanted to start mentioning how I feel to be one of the presenters today, and to share some of my practical experience be part of a community with professionals with an interest in historical construction. I learned a lot being part of CHSA. So I guess I wanted to share that. Thank you everybody for joining us today. Today I will be speaking about my experience as the structural project manager of structural renovation of the Dunwoody College project of the building school, which included repurposing an underutilized gymnasium, expanding it vertically to create a second floor for a state-of-the-art learning commons and a welcome center. A surgical approach was used to create this structural infill without exerting or limiting exerting any additional loads to an ancient type of deep foundation system built in 1924. This project is part of a comprehensive plan to transform, or that aims to transform Dunwoody campus to better meet the future needs of Minnesota's workforce. So throughout the presentation, we'll try to address the following items: the history of the building, a little bit of a description of the renovation, the process that we use, some of the engineering challenges, and some of the work and involvement with during the construction administration phase. My hope is that today we can learn importance of understanding the context of our projects, whether they are like historic or just existing. Also, an approach to diagnose and analyze the existing structures. I will briefly describe the structural systems we use to achieve that, and the engineering criteria used, and the importance of using material testing as part of our work. And a little bit mention about the role of a preservation engineer that is oftentimes how the people refer to professionals involved in existing buildings. As Peter just mentioned, our building is located just right outside the downtown Minneapolis to the southwest. You can see this image from Google Earth. We have a few beautiful buildings in Minneapolis that deserve to be kept and preserved. So I'm lucky enough to be able to work with a company that with MBJ and get involved in a few of these buildings. A little bit of the history of this building. This project, it was originally called the William Hood Dunwoody Industrial Institute. It was founded by Tait and William Dunwoody. Both of these individuals were co-founders of the Washburn Crosby Company and the Northwest National Bank of Minneapolis, which in turn evolved into General Mills and Wells Fargo, respectively. This college was originally created to be a place where young people, without distinction of account of race, color, or religious prejudice, could learn the trades and craft and fit themselves for the better performance of their life duties. So the initial programs that included tractors school, baking, auto mechanics, carpentry, printing, etc. That kind of subject. So at the time the facilities were completed, the enrollment was about just 500 people. Today is about 3 to 4 times, and there are about 250,000 alumni, and many of them are respected industry leaders in the Minnesota, and everywhere else. A little bit about the original plan. I guess I stated in my on my slides that the owners, the board of trustees, selected a very famous architectural firm to develop the project. And I just read about the way the approaches they used, the ideas that they were coming from. So several trips to the East Coast and try to come and land something that would work for Minnesota. The original project actually included five shop buildings, as you can see on the screen. These buildings actually never made it because of the economical and other constraints, financial constraints. But two of the buildings actually got built, and I'm going to show you a few images about that. So this is the east and west shop buildings, and they were built in 1917. And then a few years later, the administration building was built, and there was a gym to the southwest side of that building. Here a little bit about that on plan, just kind of to be clear what are we dealing with. The 1924 building made it to this phase of the renovation. There will be other phases that will be hopefully completed in the next few years. But the 1917 building in yellow and the 1924 in blue. There are some other additions that were made at a later time that are not part of this presentation. A little bit about the project, the schedule that of the project. There were about 8 months spent for the design phase. There were at the beginning of our involvement in late 2015, we conducted a lot of feasibility studies. Essentially, what we did is study the structure, get documentation, original documentation, evaluate the capacity of floors and systems, and with the strong leadership of our project partners, design and construction was achieved in a very tight schedule, I would say, for the kind of building and the lack of I guess knowledge of the systems that we were encountering. The project the budget is estimated to be about $8 million, and it was funded by alumni, industry partners, and other friends of this college. So moving forward, a little bit of the description of this phase, we call it phase 1 of the project, was to reuse a 24,000 square foot underutilized gym that we can see here in zoom to the right image. Locker rooms and bleachers of that area were carefully and systematically removed using state-of-the-art robotic demolition equipment to protect and limit the structural demands to the existing structure. We can see a little bit about that, and I hope that the next image will provide a little bit more clarity on this. So this area describes the gym, and the goal here was to maximize the use of the spaces around this area and limit the additional load exerted to the existing foundation. I will talk about this a little bit later. But all the new loads, in particular, the idea was that all those new loads should be supported by a new system and foundation. So there was all this existing ceiling that was actually concealing a mechanical system that provided service to other areas of the building. There's the gym. There is a crawl space that I will tell you some stories about that. It's quite interesting what we were finding there. The existing bleachers that eventually got demolished, and some other underutilized space. Right above the bleachers, there is a materials library that we had to keep intact and work around it. The new project actually included a new college admissions department, and the space was designed to accommodate events of up to 200 attendees, and provide spaces for students to collaborate and work in multidisciplinary projects. The actual admission center was located at a different area of the building, but since this is a prime space of the campus, they wanted to relocate that here. The second floor, on the other hand, was actually dedicated to a learning commons and includes a library to the southwest, technology for research, classrooms, and multi-space for faculty and student collaboration. This level actually features an atrium to the north. These yellow kind of boxes are describing one of the cool I guess features of the new architectural design. And this wall actually was renovated to be one of the I guess one of the key aspects of the project. A few sections, I will not go into the width of this much, but I want to show what is the process. We built a new foundation system. We installed new columns, and then we installed the floor system. The construction sequence for this project was key. It was important to get involved in the decision making on how are we going to do this. So it is respectful to the structure, but it's also assuming cost and safety for sure. So a few doors were made to some existing walls to be able to provide the access that is needed for this area. There were a few historic vaults that had to be protected and at the same time were posing constraints to the project. But we coordinated kind of in a way that everything worked for the architect and also for the programming of the project and the architectural features. One of the things that it's important to note here is the presence of all the existing, I guess, strengthening projects, strengthening of the floor. One of through the process of reviewing the documentation and some other references, we figured out that there were problems with the foundation system of building like at the very early times of its construction. A little bit about that wall that I was describing, the north wall of the gym, featuring some windows and door openings, a new floor opening, a new door and floor opening to create access. There were lots of different elevations and levels of this building that were difficult to navigate. A few openings in walls at the exterior. It was very important for us to review original drawings and photographic records to understand what was part of the original project and what was actually done at a later time. A few images of the renderings created by the architect, kind of describing the intent, the design intent of the top floor and the bottom floor. I'd like to discuss a little bit about the approach that structural engineers have to, or it is recommended to follow. Some of the big challenges, one of the big challenges that we face is the need to recognize that sometimes there are conflicts between preservation and commercial development, right? For this building in particular, creating more footprint, building more buildings around the campus was not necessarily the first and the best option. We believe that through the coordination with the team, we were able to reuse and maximize the spaces. In order to do that, we believe that using scientific principles, scientific approaches, such as documenting, reviewing documentation, drawings, books, etc., actually helps saving time and in turn actually budget. There's a lot of observation that we have to do in the field, Sometimes we have to do some non-destructive testing or hopefully non-destructive testing. There's a need to do some structural modeling, some feasibility studies to design whether is I don't know a more standard technique or carbon fibers or et cetera, et cetera. So there's a lot of information out there. There's a lot of construction administration involvement that a preservation engineer have to go through. And sometimes it is recommended to go and take a look at what we've done, right? So this is a little bit a description of the approach that we use when work with existing buildings, right? So the three main points is identify, investigate, and implement. We really believe that using this sort of approach actually leads to successful outcomes. Identify our items like visual mapping, systems identification, load map, damage survey, historic survey, and so on, right? So we also as I mentioned, we do sometimes minor destructive testing, geotechnical studies and material properties, as well as structural analysis and the implementation of our solutions, right? So creating those construction documents. A lot of times this type of buildings or projects require some internal QA and QC and communication with the contractor to find the most appropriate solutions. Some of my images of the site visit, I'm always a proponent of getting out there and see what we are dealing with, right? So we were very lucky that we were not far away from this building, but even if it's far, it is a good idea to get out there and get first-hand information from the buildings. One of the very interesting, I guess, challenges we found is the foundation system of this structure. It has gone through various attempts, various campaigns to try to stabilize the structure. So that's why it was critical to actually try to not exert any loads. So talking to facilities managers or other people involved in the maintenance of buildings is key for like a good understanding. A few part of the I guess investigative work is do some review of photographic records. It's just amazing how much you can learn from an existing building just by looking at photos. These are photos of the gym. This is the bleachers and actually some of the work that the students were conducting throughout the years. These photos are from about 1940. A few other photos showing when the gym was occupied. It was a good venue to actually host events. To a structural engineer like me, this is just looks like a load test, and it is an interesting thing. Eventually, the event like graduation day was moved out, and that's kind of one of the reasons that this space was hardly used by the school. So throughout the research, we actually found some photos of the construction time, like the construction of the foundation. So there's a great publication that former president at Dunwoody actually worked on at the 100th anniversary of the school, and it provided not only photos but also great information about the performance of the foundation. A few more photos and plans, blueprints. This case is like not blue, but this is just also really cool. I really love this photo because not only provides information about the buildings, the building and the some of the features that we were interested in, but also conveys the importance of the training post World War II. And the kind of the role that it plays in for the Twin Cities. So part of the historical survey, we actually reviewed about 300 plans, and it's quite overwhelming when you think about it. I would recommend to look for repositories of existing plans and all construction documents in the places that we were practicing. Some of one of the best resources here is the University of Minnesota, the Northwest Architectural Archives. And it's also important to create a system to actually deal with that sort of level of information. We believe in finding, or I believe in mapping my research to be able to understand phases, structural capacity. So we did a little bit of that at the early stages of the project, as I mentioned. Reviewing every single piece of documentation will probably save you a lot of headaches down the line. These were some records of pile installation, some of change of orders and foundation reviews, foundation details, I'm sorry. Understanding all drawings is not always like a straight path, especially for younger engineers. And I strongly recommend you to consult senior staff of your offices or even some other colleagues. It may provide you ideas of what you're looking at and save you time for the project. It is also key to be able to identify alterations. Alterations of buildings like these are just numerous, and do it in a systematic fashion is also helpful. In this case, it helps us identify the alterations to the foundation systems when we were trying to engage a new geotechnical partner to actually determine capacities and so on of the soil. As far as the structural system of the existing building, the system consists of a proprietary one-way raised slab floor system with clay tile and concrete topping. The concrete there are concrete girders supported on pile caps and on reinforced walls at the perimeter of the building. The roof building is actually framed with steel riveted trusses supporting a prefabricated concrete system. Talking about the floors, I strongly recommend to look at the work and research of Matt Stewart. I believe he's actually part of this, but I guess he is attending this presentation. I found it super helpful, all the work and that he's published in different magazines and so on.
Kevin, I'm going to have to cut you off here because we're out of time actually. So.
Oh, okay, I will just summarize quickly in 1 minute. Okay.
Hurry up.
Okay, so there were lots of studies conducted for the soil. There was a lot of problems with the soil, as I mentioned. So we work with our geotechnical partners, and we use a lot of good reference that are out there for existing buildings. We made our assumptions. We understood the age, the vintage of the building, and again, it's important to do your research. Some testing is always a good idea to validate your assumptions and models. Sometimes metal chemical analysis is important. And modeling and understanding your models is important as well. So a few details of the construction, the foundation. We have constraints with height, so we had to adapt the system so we could build that. Some photos of the construction. It's important to also get out there and make sure that. And in addition to special inspections, that the things are going the way that you intended. So my takeaway is that a systematic approach is always a good idea. No, we can base this on scientific methods. Keep solutions simple and based on solid concepts of structural engineering and active coordination with teams is always important. So. These are a few photos of the finished product. We're proud of the work that we did as a team, and the spaces are being enjoyed by the students. Thank you very much for for listening. And these are a few acknowledgements for the partners of the projects. I'm sorry for being a little bit beyond the time, but it's really hard to condense everything. Appreciate it.
Thank you, Kevin. I want to return to, so basically, first of all, Sarah's answered some questions as in written responses. I'm not sure if everybody can see those. But I want to ask a broader question, Sarah, and that is, the early I-beams were wrought iron. What is the difference between wrought iron and steel structural members?
Well, wrought iron is a it's not a uniform product. It's basically fairly pure iron, and it has less carbon in it than steel, and so the carbon in the steel is what makes it stronger in compression than wrought iron was. But really, something I'd rather like to stress is that wrought iron is not that different from steel. It's made in a different way, but there's a presumption that when steel came along, this was sort of a killer app. It just really transformed structural technology. Wrought iron can do basically what steel can do. It's just it can't be manufactured on as mass a basis as steel can, which is why steel eventually replaced it as a structural material.
I'd just like to jump in here for anybody that's out there in the audience right now. You're welcome to hang on there and we can stay on here for as long as you'd like to answer your questions. So, but to those of you that need to leave, thank you very much for attending. We really appreciate it.
Yes.
Go ahead.
Thank you all.
Thanks. I want to repeat one of the questions that you answered in a written form, Sarah, and that is, do these mills issue design manuals or guidance to encourage the use of their sections, so for the benefit of everybody?
Yes, as a matter of fact, these mill manuals were very important and highly relied on by architects and engineers. And they were actually quite elaborate. So they were both catalogs essentially of the products of the mills, and also they included information for design. So, for example, and a lot of these are available on Google Books or the other internet libraries now, and so they have a lot of excellent information, which if you are working on a building renovation and you find these obsolete sections and so forth, assemblies, you can get good information about what the intended performance and so forth was for those from these mill books. This is 19th century, and it continued up into the 20th century. But here's a Bethlehem one from the 20th century. But they started in the about the 1870s.
Thank you, Sarah. That's absolutely fascinating. I have one more pointed question that came up in the chat column before moving to Tait. And this is a very pointed question. Weren't the rail beams used in shipbuilding also?
Yes. So that beam, the asymmetrical one with the round top, eventually, and you'll see them in the the design books, they're called ship beams. So these were used for ship decks. And I guess not only did you not need the flange at the bottom, but you would hit your head. So the round bottom was, superior for a deck beam. But when they were first rolled, actually that initial rail beam that Trenton rolled was on a pattern of a rail that the Camden and Amboy Railroad ordered, thinking that a heavy, tall beam would last longer as a rail. And it, eventually that, was a failed idea. But that was, Trenton had had some experience rolling that kind of heavy rail. But still, it was quite hard to roll. And somebody asked, like, why is it hard? It's heavy, it's deep. The wrought iron is made, it's not like a continuous, billet. They're actually little balls to the wrought iron is welded together. So, and the shape of an eye is, symmetrical. So this was a challenge for them initially to roll.
Thank you very much. So Tait, you've also been kind enough to type in some responses, but I want to get to a broader question before revisiting a couple of those. The broad question is, did other manufacturers sell products for storefronts to compete with Conair?
Yes, they did. And Conair was really the dominant market player for many years. In fact, in the very early days of Conair, PPG reached out to really buy all the patents, and Plem decided not to go with that, what would have made him a very wealthy person at that time, and instead developed a company. As time went on, Conair also found themselves rubbing up against and in conflict with patents by other companies such as Zuri, Z-O-U-R-I. And instead of going to battle in courts over patents that Zuri held in terms of using aluminum for certain frames and systems, Conair instead purchased Zuri and then continued the name Zuri for one of their product lines. So they definitely were in conflict, but also merged over the years. And of course, as you know, it all ended whenever Conair itself was purchased by a former rival in some degree, Alcoa.
Great, thanks, Tait. I have to make a little plug. You have an essay in a book I edited called Constructing Building Enclosures. So it's really nice to see you're here presenting a different topic, related topic.
Yes, thank you.
To aluminum. A pointed question that you already responded to, but I want to share is, are Conair's business records intact enough to have a list of their projects by location?
They're not, but some of the most robust archival records that you can find in terms of a manufacturer is Alcoa, because Alcoa was sued so many times and involved in disputes with the federal government concerning monopoly. Many thousands, boxes and boxes of their records are preserved. But unfortunately, Conair's were not absorbed into Alcoa until after Alcoa was forced to preserve all their records and keep them open to the public. So the exact location of many of their, I'd say the vast majority of their hundreds of thousands, if not more than that, product sites are not known.
Great. And one more question before Peter, you can ask a question, maybe panelists will have something to say, but it has to do with labelings and markings on Conair products. Is there a history of doing that, or how far does that go back?
There is, but only, as far as I know, only on the doors. So you probably have seen it many times, the little Conair label at the bottom of the Conair door. That typically is a signal that the frame itself around the windows and part of the overall storefront package is a Conair product or Conair product. But as far as the frames goes, I have not seen markings.
Peter, do you want to interject with a question, or I can't? You're on mute because I have one more question for panelists.
I was just going to ask Tait, so do you know when they first introduced or first piloted the thermal brake within their systems?
No, I don't. I do not. That's a very interesting question to follow up.
That's a new area of research for you. There you go.
I like that.
Great, thanks. And so Kevin, very briefly, what were the biggest challenges you faced?
Yeah, guess the determination of the capacity of the existing foundation, I guess I didn't have the time to describe that that this building is actually sitting on the old Vasquez Creek, which is it's part of a system of glacial era rivers. It's kind of, I guess, there's a lot of organic soil underneath this building, and just determining the capacity of the existing elements, and then actually determining what is the best system to use here for the structuring field. So as I mentioned, we didn't want to shed any load. So working with the geotechnical engineers actually to determine the capacity and then and designing the new elements was key. The overhead, I guess the overhead restrictions were also key. So, but I think we ended up with a pretty good outcome, and it was good to work with the guys. So.
So you kind of honed into something that an audience member, Richard Freeman, had asked, and what kind of foundation was put in? Caissons? I seem to notice spread footing.
No, we actually the existing system is actually a hybrid system. Like, it's called a composite pile. That is the bottom portion is wood, and the top is concrete, unreinforced concrete. But the new structure is supported on helical piers. It's a system that we've been using quite a bit in several projects of this kind. So, but again, the contribution of the geotechnical engineer to determine the capacity, the phenomena like drag forces or down-drop forces, product of consolidation of soils, and that kind of things, happening in organic materials is key. So,
thanks, Peter. I'm cede to you again to bring us
Well, I
home.
think if there's no other questions from the panelists to each other, I think we can call a halt to these great stories. Shall we say, Sara steeled the show to show a window onto a new technology solution at Dunwoody. So, well, that was kind of corny, wasn't it? Anyway, I just want to say thanks to everybody that's still on the line for joining us. If you are not a member of the Construction History Society, please consider joining us. It's a small community of history lovers. So please welcome aboard. Melanie Fierst will take care of you in that department. We do have our biennial event that was postponed last May for reasons everybody knows why we're on Zoom now, is being rescheduled for this spring, Zoom or not. So either in person or via Zoom, we plan to hold our biennial event this coming May. So we welcome everybody to join. And with that, I want to thank all of our panelists for taking the time to present here today. Clifton for navigating all the questions, Melanie for keeping us all together, and of course to Paul, who is keeping the control of this whole presentation. So thank you, Paul.
No problem.
Everybody, have a good day. Be safe out there and enjoy the winter.
Bye-bye.
thank you. Bye-bye.